Hi guys, so today we're gonna discuss the problem integer break. So it is problem number 343 in Leetcode. So yeah, let's go. So the problem says given an integer, break it into sum of k positive integers where k is greater than 2 and maximize the product of those integers. Okay. So we will be given an integer. We need to divide that integer n into sum of positive numbers and we need to maximize the product. So for example, let's say 2 here. So 2 we can divide so 2 we can divide like 1 plus 1 and maximum product will be 2 itself. So since it says k is greater than or equal to 2, we cannot write just 2 as 2. This is not acceptable because k is greater than or equal to 2. We need at least 2 elements in the sum. Okay, so let's go over another example that is mentioned 10. Okay, so for 10, so we need to maximize the product. So let's see all the ways how we can divide 10. So we can divide it into 9 plus 1, so the product will be 9, and also we can divide it like 8 plus 2, the product will be 16, and so on. So the maximum product as given here is 3 plus 3 plus 4, which is 36. So now how can we come till here? So let's see. Yeah, let's see how we can achieve from 10 to how we debug something like this. So yeah, so let's see. For 10, right? If we can write it as 9 plus 1, 9 plus 1, or 8 plus 2, or 7 plus 3. I'll expand it further. Right now I'm just writing it something like this. As I'm taking k as 2, and then we can expand it from there. So 6 plus 4, 5 plus 5. Right. The next possible 4 plus 6, 3 plus 7, we have already written it. So out of these, the maximum possible will be 9, 9 star 1 is 9, 8 star 2 is 16, 21, 24, and 25. But here we can divide this 8 further, this 9 further, this 7 further, and 3 further, 6 further, and 5 further. So here if we just think of it like this. So if we know the answer for 6, the maximum possible answer for 6, and maximum possible answer for 4, and maximum possible answer for 5. So it breakdowns into finding the maximum possible answer. So it's like a recursion. So if we know the answer for earlier possible numbers, then yeah, we will know the answer. Based on that, we can compute the answer for this. So so yeah, it's typically a DP problem. So yeah, let's see how we can calculate the answer for 6 at least, and then let's see how do we do it for 5 and all. So the base case will be for for 2, let's for 2, the answer would be 1, and for 3, the answer would be 2. As we can divide it uh, like this only. Okay, so for 4, the answer would be 2 plus 2, which is 4 again. Okay, so now 5, let's see. 5, we can divide it like 2 plus 3, or 4 plus 1, or 2 plus 1 plus 1, right? So So now, yeah, we know the answer for 4. It will be 4, and we know the answer for 2. So here we need to take maximum of, so for 2 here, and see the answer is 1, but we can, I mean, instead of breaking it further, the answer, if we take 2 itself, the answer will be more. So, I mean, it will happen for 2 and 3. So we will have this base case as if number is less than 3, we will not divide it further, and we can return the same. So here for 2 and 3, we do not break it further. So answer will be 2 star 3. That will be, for this, the answer will be 2 plus 3, 2 star 3, that will be 6. And for 4 plus 1, we can break 4 further. But then, yeah, for max we have for 4, the answer will be 4 only. 4 star 1 will be 4. And then 2 plus 1. So this is something like this. So this we have already covered. So yeah, see, as I mentioned, for 3, we no need to break it further. So these are the only 2 possible ways how we can divide 5. And let's go for 6. So the answer will be for 5, it will be 6. Okay, let's write for 5, it will be 6. Okay, now let's calculate it for 6. Okay, so for 6, we can divide it like 5 comma 1 or 4 comma 2 or 3 comma 3, right? So the maximum possible will be 5 for 5. I mean, if we divided it further also, the maximum possible value will be 6. So it will be 6 star 1, which is 6. And for 4 comma 2, for 4, the maximum possible value will be 4. And for 2, it is 2. So 4 comma 2, which is 8. And for 3, the maximum possible value is 3. I mean, as I mentioned, so for anything less than 3, we can take maximum of that number or this one, so which is 3. So I mean, we don't need to divide it further, but here we have divided it because the constraint is k greater than or equal to 2. So here, so for 6 it is, for 3 comma 3 it is 9. So the maximum possible value for 6 is 9. Okay, now let's calculate it for 7. So, I mean, observe the pattern, guys. So here, pattern. So for 7, if you go, we can divide it like 6 comma 1 or 5 comma 2 or 4 comma 3. Yeah, and that's it, right. 3 comma 4 and other will be followed, right? So now let's calculate. For 6, the maximum possible will be 9. So 9 star 1, which is 9. And for 5, the maximum possible value will be 6. So 6 star 2. So 6 star 2 is 12. And for 4 and 3, the maximum possible value will be 4 star 3, which is again 12. So for 7, we can write it as 12. Okay. So just hold on, guys. So here we're getting some pattern. So let's calculate it for 8. Okay. 8, we can divide it like 7 comma 1 or 6 comma 2 or comma 2 or comma 3 or 4 comma 4, right? So now, so for 7 comma 1, for 7, the maximum possible value will be 12. So which is 12. For 6 comma 6, for 6, the maximum possible value is 9. So 9 star 2, which is 18. And now for 5, the maximum possible value is 6. 6 star 3 is 18. Okay. And now for 4, maximum possible value is 4 again, 4 star 4 is 16. So here for 7, for 8 it is 18, right? So let's do it for one more number. Let's do it for 9. For 9, we can write it as 8 comma 1 or 7 comma 2 or 6 comma 3 or comma 3 or 5 comma 4. Right, so here let's quickly calculate. For 8 it is 18, 18 star 1 is 18, and then for 7 it is 12, 12 star 2 is 12 star 2 is 24, and for 6 it is 9, 9 star 3 is 27, and for 5 it is 6, 6 star 4 is 24. So, for 9 it is 27. So, so yeah, I hope you understand. So here this is a typical DP problem. So yeah, let's go ahead and code this. As I mentioned, for the base case, if n is less than or equal to 3, then we can return n minus 1. Means here the number will be from 2 only, so we don't need to handle the case where n is 1 or 0 because the number will start from 2. So yeah, after let's initialize the dp of size and dp of size n plus 1. Now let's put the values for a few cases. Okay, dp at 0 mean this will not use, we can just put some garbage value. So for 1, so we don't use. For dp at 2, so even though the value for 2 is 1 only, let's put it as 2 because I mean here if you observe we are taking, I mean for this purpose we are not dividing it further because we have earlier values. Also if it is less than 2 we are anyhow returning from here. So just for calculation purpose let's put our dp of 2 as 2 and then dp of 3 as 3. I mean we are not dividing it further. And now current I equal to yeah, 4 I less than or equal to no, I less than or equal to n I plus plus. No, so let's put our dp of I as 1, let's say. So now for int j, so we are iterating backward and we are seeing what is the maximum value. So for int j equal to, I mean, let me write it and you'll understand. I minus 1, j greater than or equal to 0, j minus minus. So here, dp of I equal to math dot max of dp of I comma, what is it? So other one will be, we will be splitting till j and the remaining part. So it will be dp of I whatever, yeah, it is there till now, I minus j dph, right? So at the end we can return dph 1. So run this, that's third. Let's quickly submit it and see. Yep, it got accepted. So yeah, so as guys, this is the problem. So here they are mentioned. Yeah, I mean, we have one more solution which is optimal than this, which is of order. I mean, this solution is taking n space, order of n space, and order of n square complexity. Yeah, we have one more solution which takes no space and can be done in order of n time. So let's discuss it later in the next video. Yeah.